My dear friends, welcome back to Be Spice. This is Bala with you. In this session, we'll focus on-off wall design and specification, wherein the subject is on the actuator types. Okay, so hope you had watched my previous session on valve design, where we have covered the valve types of valve extensively with its application. So I have given both the videos in the same playlist. You can watch and get benefited. Okay, let's move on with the details, friends. So before going into the types of actuator, I want to touch upon a bit, friends, on the outline actually. Normally we go with the spring return type piston actuator. Okay, as much as possible. That is the point. You see here, this is your single acting. This is what we call it as a spring return. See here the pressure port. This is your pressure port, and on acting of pressure, this is the spring. So it is getting extended. Okay, this is your extension stroke, and this is your a return stroke. Okay, so this is your vent port. So this is a single acting. Okay, pneumatic double acting piston actuator shall be selected where the spring return actuator, this guy cannot cover the required thrust and length of the stroke or stroking speed requirements. So only that, particular application we go for this. Otherwise, you go with this. So here, if you see the double acting, you see here, this is your pump flow direction, right? So it actually, this is a piston, this is your extension stroke. Okay. Then this is your return flow, right, friends? So here, if you see here in the return, this is your return stroke. So the pump flow is this direction and the return flow is here. This is the typical double acting. Of course, I am also going to cover the valve, torque calculation, all this. Don't worry. This is just a beginning, just a beginning. See, what I'm going to cover you, friends, I already given the valve design. Okay, so I hope that is useful. Okay, so this is focus. This will focus more on the actuator. The next one, we also talk about the parameters, which are impacts the actuator selection. Those things. Then the valve torque calculation. Then after that, we'll also focus on the actuator, sizing. Okay. Then finally, we'll go to the data sheet. So in a nutshell, the whole thing, the whole aspects related to on-off well will be in our B-Spice. Okay. Okay. Coming back to the subject. Okay. Where a pneumatic double-acting piston is selected. Where a pneumatic double-acting piston is selected. Okay. So we need to ensure the air volume tank, preferably stainless steel. Okay. In fact, I'm also going to cover one more video on this accessories, on all accessories in the on-off valve. Okay. So this one you just take note. And actuator, of course, shall be fabricated as per manufacturer standard. The maximum pressure rating of the actuator assembly shall be permanently stamped on the actuator or on the bar and nameplate. You know better. The persons, I mean, experienced professionals know this, but yeah, just want to update you. Okay. To add on a few more actually, see, this also just want to add on. Actuator shall withstand the instrument at design pressure in line with the basis of design. What is your basis of design? In line with that, you have to design that. Okay. In case the actuator rating is limited, vendor says it's limited, then we have to go for a pressure relief device after the air filter regulator. So this is the point. Okay. Of course, actuator shall have a mechanical stem position indicator with marking open and close position. Okay. So this is about the outline. Okay. Now I'll go into the actuator types. Okay. First, we'll talk about the hydraulic actuator. See, what is this hydraulic? Hydraulic actuator is a cylinder that works on hydraulic power and converts into a mechanical work, right? As you can see here, this is your cylinder, this is your scotch and yoke, and this is your spring mechanism. So maybe, if you go for an interview, they may ask, okay, what is the, mechanism here? This is the scotch and yoke mechanism. Yeah. Hydraulic type. Okay. So, yeah. Yeah, scotch and yoke type rather. Yes. So, hydraulic actuator can be quarter turn, which are used for ball valves or linear, which are selected for linear valves such as globe valves. This is also one of the things. Quarter turn used for ball valve or linear for linear valves such as globe. Okay. So the point to note here, friends, high pressure oil in a pressure range between 100 and 160 and 200 enters the cylinder of the actuator, okay, and pushes the spring back, okay, pushes the spring back and transfers the linear movement here, linear movement here, quarter turn degree through a scotch and yoke. So that is how it works actually. And the pressure, high pressure in oil, high pressure oil in a pressure range of 160 to 200 enters the cylinder of the actuator, cylinder of the actuator, pushes the spring back, pushes the spring back, and transfers the linear movement through this quarter turn through scotch and yoke mechanism. Okay, so this is the simple outline. I'm going to also talk about in detail actually. See, hydraulic actuator, in spring return, the piston is pushed back in the piston side through the force of the hydraulic fluid entering the cylinder side. So this is your fluid. Okay, so this is your chamber, this is your housing, this is your piston, this is your piston yard, piston rod, right? Okay. So as you can see here, friends, the piston is pushed back. This is your piston, right? It is pushed back through the force. This is your fluid force, right? Pushed back through the force of the hydraulic fluid entering the cylinder. Okay. So this is your fluid extension and spring return here. And this is your single action. Okay, one side. Okay, right. So there is no scotch and yoke in a linear actuator. So this is what I want to say. There is no scotch and yoke in the linear actuator, so that the movement of the actuator piston rod that connects to the valve stem is linear. Here it will be connected, right? So it will be linear actually. There is no quarter turn, all these. This is linear. Just remember, there is no scotch and mechanism here in this. Okay. Whereas the scotch and mechanism is here in this type. Okay. Just get to know that is in the quarter turn. Okay, friends. Right. That is a point. So I'm explaining the linear aspects here. Okay. Yes. So it is possible to have a double acting hydraulic actuator utilizing pressurized oil on both sides. So we can also have a, double acting. Okay. In the one I explained earlier, right? Yeah, the same principle. So we can also have a double acting here. You can see here, this is your hydraulic fluid pressure. This is one. And here, this is the hydraulic fluid pressure. So it is possible to have a double acting hydraulic actuator utilizing pressurized oil on both sides, this side and this side. So if you see here, friends, this is your direction. Fluid return to the reservoir here. This one, fluid return to the reservoir. So this is the extension, right? So the fluid force acts and, see, it's actually movement. It's extending and the fluid also, returns to the reservoir. Got it, right? And now you see here, this is your fluid force. Here, this is your and direction is like this. And here the fluid returns to the reservoir. So this is the double acting. Okay. So here also there is no spring in double acting to move the valve in either open or closed position. Here there is no spring. Just remember, friends, here there is a spring, single spring return, but here there is no such spring. Okay. So this is about the hydraulic actuator. I hope you got some insights. Okay. Now we talk about the actuator hydraulic type advantages. Hydraulic actuator are smaller. Hope you know that. Than pneumatic actuator, since oil pressure is higher than air. So less oil is required to move the spring compared to air. You got it, friends? Yes. So hydraulic actuator are smaller than pneumatic actuator since oil pressure is higher than air. So less oil is required for moving the spring, okay, compared to air. However, hydraulic actuator is thicker than pneumatic, due to higher oil pressure. Yeah, the construction, right? It's a thicker, right? Okay. So, for example, air pressure in a pneumatic actuator is 5.5 to 9 bar, which is much lower than oil pressure. So, that is also another point you need to watch out for. Just remember, friends, air pressure in pneumatic actuator is 5.5 to 9 bar, around that actually, which is much lower than the oil pressure. Oil pressure, which is much lower than the oil pressure. Yes. So, um, yeah, hydraulic actuator are good choice for large size and high pressure class valves having a high force or torque requirements for operation at high speed. Hydraulic actuator are good choice for large and high pressure class valves. Okay, friends, you got it right? Yes. So, hydraulic actuator are more precise than pneumatic actuator. Since hydraulic oil is not compressible. That is the point you note. Hydraulic actuator are more precise than pneumatic actuator. Since hydraulic oil is not compressible. Hydraulic actuator has a high degree of corrosion protection compared to air, which is important in corrosive environments such as offshore. This is also we need to note. Hydraulic actuator can reach the safe predetermined position, open or close, after losing the source of oil power through spring force. So that is it returns, right? So it returns actually. Okay. So that is the point. And of course, pneumatic also returns. Yeah, just want to, just touch upon a bit of, what do you call the advantages. Okay. So to sum up, friends, this is very important actually. Smaller than pneumatic actuator and hydraulic, actuator is thicker than pneumatic due to higher oil pressure. For example, oil pressure of pneumatic actuator is 5.5 to 9 bar only, which is much lower than the oil pressure. Now, that is the point. Maybe you may get confused. The point is hydraulic actuator is thicker than pneumatic due to higher oil pressure. Okay. What I'm saying is here air pressure for actual pneumatic is 5.5 to 9 bar only. This is much lower than the oil pressure. So the oil pressure for hydraulic will be much higher. That's what I want to say. Okay. I hope it's now clear. Okay. Hydraulic actuator are good choice for large size and high pressure valves, having high, force or torque requirements. Of course, I'm going to take a class on torque requirements also. Just, stay tuned. Okay. Hydraulic actuator are more precise than pneumatic actuator. That is also we need to watch out for. So I'm repeating because it's very, very important. Okay. So high degree of corrosion protection. Okay. And yeah, that's it. So these are the advantages. Then we'll go into the disadvantage. Friends, this high pressure of hydraulic fluid is complex to manage, it requiring many safety and environmental precaution. Obvious, right? No choice. Yes. The control system of hydraulic actuator is larger and more expensive compared to pneumatic. So that is also you need to watch out for. Yeah. It will be a very big panel kind of thing, right? Yes. And of course, expensive. Yeah. So that's about the hydraulic. Now, I go into the pneumatic, which we know very well, right? We use day to day, right? Pneumatic actuator. So this is the look and feel again. As cylinder, you have the scotch and yoke. Yeah, this is your spring piston. Okay, friends. So pneumatic actuator are very simple devices that convert the air pressure to mechanical work. Very simple. So the working principle is same as the hydraulic, but they work on, oh sorry, I think typo error. Work, but they work in air instead of oil. Yeah, yes. So this type of actuator could be either linear or quadrilateral. Yeah. So for example, air pressure that enters the cylinder right here is between 5.5 and 9 bar. This is what we discussed earlier, right? Yes, this is the one pneumatic. Okay. Now, we talk about the advantages, friends. Pneumatic actuator run on compressed air, which is readily available, safe, and environmentally friendly. Environment friendly, okay, unlike oil. So, they could be the best option in hazardous area. Remember, you cannot use that in, hazardous. I mean, the hydraulic one is not suitable for hazardous. Of course, you can do it, but, you have to come out with a lot of, stringent requirements. Okay, right. So this is the point. Control system of pneumatic actuator are relatively inexpensive, right, friends, and more compact, right? So you hope agree, right? So this actuator provides high speed operation and returning to a safe position in case of air power source is lost. Unlike electrical actuator, electrical actuator it fail last, right? So it will not reach to the safe position. So this we have advantage and also speed, high speed. And it also has a disadvantages. Pneumatic actuators are more costly compared to electrical. I'm not comparing with hydraulic, but I'm comparing with electrical. Yeah, this is costly actually. People may think electrical is How costly? No, pneumatic are more costly actually. So air is a compressible fluid which can jeopardize the accuracy of the pneumatic actuator. So this is just minor, disadvantage, friends. That's it. This is about the pneumatic. Then we go to the electric. This is the look and feel, right? See, it's a complete mechanism is in a one, enclosure, friends. As you can see here, this is your base, this is your body, this is your limit switch, torque switch, this is your terminal, this is your capacitor, this is your indicator, open, close, this is your outer window, this is your motor, this is your heater, this is your hand wheel, yeah. For manual override, all this is a lever, all these are, okay. So electrical actuator use electrical power, right? This we all know. So in fact, electrical actuator geared motor with a different electrical accessories such as limit switches, circuit boards, all these. The motor works with a 12, 24, 115 or 220 AC or DC voltage. So this is about the electrical type. And also I'm going to talk about advantages also. Electrical power is relatively inexpensive, friends, right? Okay. So electrical actuator provide good accuracy on valve movement and functioning, and it is possible to nominate the, yeah, I think there is a typo error actually. Opening percentage of the valve. So meaning you can able to, get the reading of the opening percentage of the valve. That is a point. Whereas in pneumatic, you don't have open close only, right? Yes, that's it. All control components are integrated into the actuator, as I explained earlier. So it's very simple. And electrical actuator are cheaper, more compact and lighter than pneumatic and hydraulic. Lighter, just imagine, lighter, right? So this is about the advantages. Okay. So it also has a disadvantage. What is that? It cannot maintain fail-safe position unless they are combined with hydraulic power, electrical and hydraulic. You need to have some modification. That is one of the disadvantage actually. Electrical actuator contain more complex and sensitive components. So that one we can't avoid. Yeah, that is the type. Yeah, construction features. Electrical actuators are not as economical as pneumatic or hydraulic actuator above certain size. Okay, you got it, friend? Here, cheaper. But when it comes to some certain size, like, more than 12-inch and all, so you may not be able to, come out with the economics actually. So it may not be economical. So that is a point, right? So that's it. Electrical actuator require more certification, of course, in hazard area with explosive fluids such as ATAX, all these actually. You know ATAX, right? It stands for atmosphere explosive. It's a European Union directive, covers equipment and protective system for use in potentially explosive atmosphere. Just add on for you. Okay. So that's about the actuator type, friends. Any questions, you can write to me. Thank you for watching. Friends, I want your support, friends, nearly. Really, I want your support because, uh, nowadays I'm not getting enough support actually. If you are not getting enough support, then obviously, the motivational factor, all these aspects are there, when somebody is spending time and, preparing material, all this. So, yeah, just support me. Yeah, thank you. Yeah, next video will talk about the parameters which impact the actuator selection. Okay, then see you. Take care. Bye bye.